Hello, everyone. In this video, we're going to talk about data quality and why data quality is important to data visualization. This is related to our assignment in this week, which you need to discuss the importance of data quality and find some examples about the use of data in data visualization with poor data quality. So in particular, we will try to understand the importance of data quality and learn the basic data models and understand how to create a data set that is suitable for analysis. So why do we need to care about data quality in data visualization? So it's easy to understand, it's pretty intuitive because we all know that garbage in is garbage out. There are examples of real-world data issues we may encounter, as well as the fundamental concepts around data modeling from the perspective of data quality. So here's a press release from 2011. This is after the financial crisis, which is driven primarily by a mortgage crisis about 11 years ago. So the National Association of Realtors, known as NAR, has some of the best economists in the world constantly studying and publishing about the real estate market. Their numbers are published regularly, and the market uses numbers as a common guide for how things are in the housing market. But there's a major issue here. In December 2011, they announced that they had found an error in their numbers. It turned out it was a major error. From 2007, pre-recession, through the end of 2011, they were double counting sales of certain homes. As a result, they had to revise all of their sales numbers down. So this shows you that even for such a large organization, they could make mistakes in collecting wrong data, in actually resulting in poor data quality. So the lesson here is never trust the data. Never trust the data you collected. Never trust the data you were given. If you want to be more precise about the statement, you could never trust the assumption of the data. So if you are given a task for analyzing a specific data set, you have to challenge it, question the source, dig in and explore the data. Good data is clean, relevant, trusted, and can be leveraged. So here's a question: where do my highest value subscribers live? So if you look at the sample data here, you see we have 3 data sources, 1, 2, 3. They're actually from the same city, same state, but today actually they are represented in different formats. So this may eventually result in 3 different locations by a specific maybe designer or people, if they do not have prior experience dealing with this type of maybe inconsistency. Similarly, for the next question, which subscribers should I try to reactivate? So the database will also treat these records as separate individuals, but actually they may be the same person. So do you think Excel can be used as a database, or Excel is actually a database management system? So many businesses, they use Excel to store data. This can lead to disasters. So when we copy paste data into Excel, it's easy to miss the target or overwrite wrong cells. So Excel is essentially used for data processing, for computation purposes. So if if a business wants to use or store data in the database, they should choose specific database management systems such as Microsoft Access or many other options. So the second type of scenario is data type may be mixed up when using Excel as a database, because Excel doesn't enforce consistent data types in each column. This can lead to problems in loading for analysis. So in a database management system, we can specify the actual data type for each column. So like in this example, customer ID, customer name, order ID, date, they should belong to different data types. And it's easy to mix up or lose track of which version is right. Essentially, sometimes you may actually delete or lose the data. How do we create a good data set? So first, data can be provided in or acquired from different sources. Data can be provided in different types of methods, in different formats, such as flat file. It can be coming from queries. It can be coming from operational data stores or data warehouses. So the method by which the data is modeled has a large impact on your ability to use it for analysis. So transactional modeling is what we normally use, especially in a relational database. So relational database is the most commonly used way to store data. Normally, data will be stored in a two-dimensional table. And those tables are related to each other. That's why we call this relational databases. And data model is normally normalized. So we call this normalization. The purpose is to eliminate data redundancy, to make it more efficient to process queries. So this may pose a challenge for data visualization, especially for normalized database, because especially if you have a large database, you have to join data in order to present a big picture for all the data you want to use for data visualization. This may affect the performance of your data visualization. So if we look at this example, so this is what we call a relational database. So you see common keys are used to link concepts, which means these keys are related. So the common customer ID in order master table is related to customer ID in the customer ID table. And order ID related to the order ID in the other table. And the blue order ID is what we call a foreign key. This two brown color order ID is what we call primary key. So because this is not a database management class, so here I just want to give you some ideas about what a relational database looks like. So if you are dealing with a real scenario, this can become very complicated. You may have thousands of tables related to each other. So this may look like more complicated with many of the entities. We call each rectangular entity, which is actually just a table. So they relate to each other to make this large database. So suppose you want to do a data visualization out of this relational database, you have to clearly understand all these tables and their attributes. And many times you need to join those individual tables to grab the necessary attributes to be presented in your charts. So this is pretty challenging. So many times this may not work for analysis, especially like this case, it's very complicated. So what do we do in this situation? So sometimes actually we need to do denormalization. So denormalization is a reverse process to add redundancy to your original database. So data may be stored in a multi-dimensional database, but it will be presented in a single or small number of wide tables. In that case, you may only end up with a single table storing all the necessary data you want to use for data visualization. So this is pretty commonly used in online analytical processing, especially for business intelligence. It can be optimized for reporting and analysis as well as data visualization. So even though you may have data redundancy, this can improve the performance of data visualization. So essentially you have to look at the trade-offs between the performance and the richness of the data required for visualization. So there are two fundamental categories, or we call building blocks, in our tables. So the first one is called dimensions. The second one is called measure. Dimensions are actually texture attributes. They're not countable. They can be grouped. They can be used to group, filter, and build hierarchies. Measures are numeric attributes. They can be counted. They can be actually computed. So like on the bottom, you see these SQL statements. Select some cells. So the green color cells is a measure. It can be counted. It can be computed. All the attributes in blue color, they are dimensions. They are texture attributes. So here's another example typically used in data warehouse. It's called star schema. So this looks like a star in the center. In the middle, you can see it's a central attribute, central entity. It's connected to all the other individual entities. So this will actually make it scalable to quickly increase the performance of the data warehouse that can be used for data visualization. So let's look at an example in both Excel and Tableau. So suppose this is a single table that you want to use for data visualization. So we see multiple attributes. So what are the dimensions? What are the measures? So as we mentioned, dimensions cannot be calculated. They are actually texture attributes. On the other hand, measures are actually numeric attributes. So from this difference, it's easy to differentiate these two types of attributes. So you can see price, quantity are actually measures. All the other attributes are dimensions. Dimensions provide methods to group, organize, categorize, filter, and segment the data. Measures give the quantities and amounts for analysis. So sometimes data is not available or is missing. So you may want to use UNK means unknown to mark, or use N/A for not available. So this will make your data set complete and ready for analysis. So this concludes my video for the discussion of data quality. Let me know if you have any questions.